Hi guys, today we are going to discuss a very important topic, that is reflex klystron. But before going to discuss reflex klystron, let me tell you that in our previous lectures we have discussed traveling wave tube and two cavity klystron amplifier, and link is given in the description. So in our today's lecture we will discuss reflex klystron. We will also discuss the need that why we need reflex klystron after two cavity klystron amplifier, and we will discuss that there is a problem with two cavity klystron amplifier. So first let me tell you that what is meant by reflex klystron. So a reflex klystron is a specialized low power vacuum tube used to produce oscillations at microwave frequency. Its principle is similar to the two cavity klystron amplifier, and that is velocity and current modulation. Here velocity and current modulation means that the modification of the velocity of a stream of electrons by imparting alternate acceleration and decelerations to the electrons in such a way that they are caused to bunch together, with the result that each bunch causes a cycle of current as it passes an output electrode. So klystrons are basically specialized tube used for amplifier and oscillators at microwave frequency range. So in our today's lecture, first we will discuss why we need reflex klystron, and then we will discuss construction of reflex klystron. After construction, we will discuss operating principle, then we will discuss working of reflex klystron, then specification, and at the end we will discuss applications of reflex klystron. So let's first discuss that why we need reflex klystron. As we have already discussed that two cavity klystron and traveling wave tube in our previous lectures, and we know a two cavity klystron act as an amplifier to provide amplification of RF signals. But the problem with two cavity klystron is that we cannot use it for generating oscillations, because basically a two cavity klystron can be converted into an oscillator, but some disadvantages are associated with it. As we know, to design an oscillator, positive feedback must be provided to the input in a way to have a magnitude of loop gain as unity. So if we design a klystron oscillator using two cavity klystron, then to have a change in oscillating frequency, the resonant frequency of the two cavity is also required to be changed, thereby leading to cause difficulty in generating oscillations. Thus to overcome this problem, to overcome the disadvantage, a reflex klystron having a single cavity was invented to have a sustained oscillation at microwave frequency. And now we will discuss the construction of reflex klystron. So the basic schematic of reflex klystron is shown below. And this is the structure of reflex klystron. The structure consists of a cathode and focusing anode that combinedly act as an electron gun for the tube. The cathode emits the electron beam which is focused inside the tube by focusing anode. Also, a positive potential is provided as input which sets up an electric field inside the cavity. As it is a single cavity structure, the single cavity acts as a buncher and catcher cavity separately. At the time of the forward movement of electron beam, it acts as a buncher cavity, while at the time of the backward movement, it acts as a catcher cavity. A repeller plate that causes the backward movement of electron beam is present at the opposite end of the electron gun, which you can see in the structure of reflex klystron. The potential at the repeller is made extremely negative in order to permit repulsion of like charges. Repulsion is necessary in order to build electrical oscillations, as output power must be fed to the input, so the velocity modulated electrons must have to travel a backward path in order to provide feedback. Thus, repeller is used in the structure of klystron amplifier. And before going to discuss the working of reflex klystron, let's discuss the operating principle of reflex klystron. Like a two-cavity klystron, a reflex klystron utilizes the phenomena of velocity and current modulation, which we have just discussed, to produce oscillations. However, there exists variation in constructional structure and the respective application of the two. A reflex klystron consists of a single cavity that performs the action of both buncher cavity and catcher cavity. As to have oscillations, feedback is needed to applied at the input, which is provided by the oscillator. While moving electron undergoes velocity modulation and the repeller applies repulsive force on them, this leads to formation of bunch of electron, and further this bunch will lead to cause current modulation. And now we will discuss the working of reflex klystron. As we have already discussed, the fundamental principle of operation of a reflex klystron is velocity and current modulation. So initially, when the electron beam is emitted by the electron gun, then the early electron, which is denoted by E sub E, experience a very high potential. Due to this, a strong electric field gets generated inside the cavity gap, leading to cause movement of electron toward the repeller with a very high velocity. And due to high velocity, the electron penetrate deeper into the region of the repeller and thus require greater time to repel back toward the catcher cavity. But when the externally applied potential is almost zero, then the electron moves with a uniform velocity with which it was emitted by the gun. These electrons are generally known as reference electron and denoted by E sub R. So in the case, reference electron will not penetrate deeply into the repeller surface and gets repelled by the repeller in lesser time than the early electron. Further, the electron that is emitted by the gun after reference electron experience highly negative potential at the cavity. This electron is generally known as late electron and denoted by E sub L, and moves with a very low velocity inside the tube. The penetration level of the late electron into the repeller space is least, thus takes a minimal amount of time to get repelled back. It is to be noted that due to deep penetration into the repeller region, the early electron will take more time than the reference electron while returning toward the catcher. This change in velocity of the moving electron is known as velocity modulation. And due to this velocity modulation, all electrons get bunched while returning toward the catcher cavity. So in this way, bunch of electron reaches the catcher cavity. This bunch of electron lead to cause current modulation inside the tube. Therefore, at the time of returning, the bunched electron transfer the maximal of their energy to the catcher cavity, thereby leading to cause oscillation inside the tube. And now we will discuss what is meant by transit time. Transit time is defined as the time taken by the electron to return to cavity gap after getting repelled by the repeller. And for sustained oscillation to take place, transit time is the most important factor. Basically, the optimum time for leaving the gun is centered around the reference electron, which is considered at 180-degree phase difference from the sinusoidal applied potential across the gap. And after transit time, now we will discuss what is meant by bunching process. The figure below shows the process of bunching on the return journey of all the three categories of electron, such that early electron, reference electron and late electron. Here the x-axis represents the time and y-axis shows the distance traveled by the electron inside the tube, which you can see in the graph. As we have already discussed that bunching takes place at the time of return journey of the electrons. Thus it is represented in figure that though early electron, reference electron and late electron are approaching the repeller with different velocities, yet while returning all of them are bunched at a respective time. So this is what we called as bunching process. So after bunching process, at the end we will discuss the specifications. The operating frequency range generally offered is 1 to 20 GHz. It delivers output power in the range 10 mW to 2.5 volt. The tuning range of klystron lies between 5 GHz to 5 GHz at 2 watt and 30 GHz at 10 mW. Theoretically, the efficiency is considered to 22.78%, while practically the achieved efficiency is only 10 to 20%. In the applications of reflex klystron, we will discuss that as reflex klystrons are oscillators, thus find applications in local oscillator receivers, radar receivers, radio receivers, and also utilized as single signal source in microwave generators and pump oscillators of parametric amplifiers. So this was our detailed lecture on reflex klystron. Hope you guys like it. Thank you very much. See you guys in our next lectures.